We need to make it a bit faster, but before that, I want to kind of re-explain to you one thing that you will need it for the next 1 hour, because in the next 1 hour, I will try my best to finish all 3 flow scenarios. Okay, in last week we have finished flow scenario number 1, but the thing is, I learned from your friend, from me. Okay, I talked to you in the tutorial, right? So I think there is something that you may miss during the explanation. So I will explain it one more time. Pay attention if you want to escape from me and do not want to meet me again next semester. But if you love me and you want to meet me again next semester, you are free to do whatever you want, right? But yeah, I believe you want to escape from this class, right? So please pay attention to this. Okay, I will explain it again one more time because this is the basic. Once you know how to do this one, you will know how to do the other 3, the next 3 one. Okay, so again, let's look at the problem that is given to you. The flow is flowing, or the fluid is flowing between 2 infinite parallel plates. Good. So it's flowing only on the x direction. Only on the x direction. Which means from 3 components of the flow, you have only u. Right? You do not have phi, you do not have w. Why? Because there is no flow across the wall and there is no flow along the z direction. No flow on that. Okay, so all flow going to the x direction only. But remember, even though we are only talking about x direction, the velocity can be different from x to x, right? From y to y, from z to z, which means the velocity in this location with the velocity in this location can be different, right? In this location, it can be 2 meters per second, but in this location, it can be 3 meters per second. Similarly, the velocity on this location can be different with the velocity on this location, right? Yes. So even though we are talking about u only, it's still function of x, y, z. Clear? So, if you are clear with that, now we list all the assumption and condition. Most of the time, the condition is given to you. So whenever you receive a question, you read it first. Okay? Some of you get too excited, you start derive it without reading it. Okay? So read the question clearly. What is the condition given to you? In this case, the condition is steady flow. If you have a steady flow, all derivative to t is 0. Because it is constant along the time, which means it's the derivative of time will be 0. Okay? Then it is incompressible fluid, so rho is constant. It's very important because when you have incompressible fluid, right, you will find later on du dx plus dw dv dy plus dw dz is equal to 0, which means you can easily slash the last term on the conservation of momentum. Okay, you don't have to think about it. Incompressible, okay, scratch. That's it. Right? Now, this is the first that I told you. Phi and w is equal to 0 because we are talking about x direction only. But our u is still a function of x, y, z. So this one gives you another advantageous because there is no variation of u in z direction, which means the u in here and u in here and u in there is the same. Why is that? Because it is infinite, there will be no side wall. So now side wall effect is negligible. Okay, so u in this z and u in that z is equal, which means u is constant along the z direction, right? So u is not a function of z. If it is not a function of z, right, you will have only u as a function of xy, because z is not there anymore, right? But still x and y give you a lot of headache. So we will do something such that u will be function of one parameters rather than two parameters. Okay. Next, gravity is working on the negative y direction, because in this case, this is your x, y, z. This is the thing that we choose. I mean, I choose, you follow. Later on, you choose, whatever it is. Okay? But in this case, because you do not know, I choose for you. Okay, so we choose this one. In this case, so your gravity will work on the negative y direction, and it is viscous fluid. Because if it is inviscid, then your mu is equal to 0, which means you will end up having only the Bernoulli equation. Okay, but in this case, we are not talking about Bernoulli equation, we are talking about Navier Stokes. Okay, so from that, we apply the continuity equation. You know your du dt is equal to 0, dv dt is equal to 0, dw dt is equal to 0, and d rho dt is equal to 0. Because that rho dt is equal to 0, this one gone. So rho you can take out. Now you have your common incompressible continuity, which is du dx. Okay, so for incompressible fluid, right? Steady incompressible fluid, you know it will be du dx plus dv dy plus dw dz is equal to 0. Okay, so this is what you will have. Now, if you have this one, you can be sure that this 3 is 0, right? So that one you can scratch now. But from here, now since this one is 0, phi is 0, right? Only u, but phi is 0, w is 0. So this one gone, you know that du dx is equal to 0. The only way du dx is equal to 0 is by knowing that u is constant in x direction. If it is constant, means it is not a function, which means now you cancel this one. Clear until this point? Because only this one I will explain in detail. The other two I will just skip. Okay, clear? So you have u equal to u as a function of y. That's all. Now, having that, you can cancel. This one is because steady state condition. So everything in t you cancel. Now du dx is 0. This one, why it is 0? It is not because du dy is 0, but phi. The phi is 0. So you cancel this one. This one is also w is 0. U is not a function of z, so it is 0. 0 times 0, 0. Doesn't really matter. dp dx unknown, we leave it like that. This square u dy square is not 0, so you keep it here. Right? U is not a function of z, and u is not a function of x. So this one cancel. Clear until this point? Okay? You do the same for the phi, but the nice thing about phi is 0. So whenever you have phi, there's 0. Doesn't really matter. And w also is 0. So whenever you have w, it will be 0. So you end up having this, okay? This is the equation that you need to have, okay, before you come up with your solution. Okay? One student asked me, do we need, will you give us the final solution of it? No. The one that given to you is this. In the final exam, in the exam, this one is the one that is given to you.